stability of free radicals, stability of carbocation, stability of alkenes is directly proportional to number of hyperconjugating structures. So what hyperconjugating structures depend on is alpha hydrogens. More is number of alpha hydrogens, more will be hyperconjugating structures. So here we are going to discuss the stability order of primary, secondary, tertiary carbocations. So what is a primary carbocation? Positive charge on a primary carbon. What is primary carbon? The carbon connected to one carbon is known as a primary carbon. A carbon connected to two other carbons is known as secondary carbon. A carbon connected to three other carbons is known as tertiary, and the carbon connected to four other carbons, does it exist? It does not. Alright. So carbocation will maximum have three carbons. So we can have a primary, secondary or tertiary carbocation. We cannot have a quaternary carbocation. So here you can see this carbon is connected to this carbon is connected to this carbon is connected to 1, 2, 3 carbons. So the degree of this carbon is a 3-degree carbon, and the positive charge is on 3-degree carbon. So carbocation is known as 3-degree carbocation or tertiary carbocation. We can also name it like that. Similarly, the carbon having positive charge is connected to two other carbons. So this is a 2-degree carbocation. Here the positive carbon is connected to one carbon, so it is 1-degree carbocation. So depending on the number of carbon atoms a positive carbon connected to defines its degree, primary, secondary and tertiary carbocation. So what is the stability order? Stability order of a carbocation is directly proportional to number of resonating structures. When resonance is not present, it is directly proportional to number of hyperconjugating structures. When hyperconjugation is also not present, it is directly proportional to plus I effect. Alright. So more is plus I, more is hyperconjugation, more is resonance, more will be stability of a carbocation. Alright. Next we are going to discuss which one will be more stable. So stability order goes like this. Stability as 1 degree is less stable than 2 degree, 2 degree is less stable than 3 degree. The reason for this is hyperconjugation. So 3 degree will have more alpha H. For example, here tertiary carbocation has 9 alpha hydrogens. 9 alpha hydrogens are present, and this one has this 6 alpha hydrogens, and this one has this alpha carbon, so 3 alpha hydrogens. So more is number of alpha hydrogens here. This one is alpha, this one is alpha, this one is, and the hydrogen present on it, this is known as alpha hydrogen. So 3, 3, 3, 9 alpha hydrogens, 6 and 3. So more is number of alpha hydrogens, more will be hyperconjugation, more will be stability. That is how it is defined. So anybody asks you why tertiary carbocation is more stable, you have to say tertiary has 9 alpha hydrogens, that means it has maximum hyperconjugation, because of that it is most stable. Alright. Next, if we have a stability order this, you can understand what the reactivity order could be, right. Next we have what happens in hyperconjugation. In hyperconjugation something like this happens. If we have CH2 plus and we have 3 alpha hydrogens like this. So for drawing hyperconjugating structures, what you have to understand is that carbon hydrogen sigma bond gets into conjugation with the positive carbon. So this bond breaks, this becomes plus and this becomes minus, minus and plus forms a bond. So you get a hyperconjugating structure something like this. Alright, and this H plus is written. So I have shown you one hyperconjugating structure when I have broken one alpha hydrogen. Similarly, what you can do is you can break this CH bond. You can break this CH, you have to do something like this CH, and the top and the bottom hydrogens are still intact. So another hyperconjugate, so this is one, this second, and you can have third hydrogen breaking, then hyperconjugating structures will be like this. So 1, 2, 3, these are hyperconjugating structures. That is how you can draw them and you can understand what is hyperconjugation. Alright, so that is it for now. Thank you.